95% of modern vehicles are engineered to self-destruct the moment your factory warranty expires. Manufacturers do not build trucks to last forever anymore. They build them to survive just long enough for you to sign the next lease. Yet, a tiny, quiet group of Ford engines completely defies this planned obsolescence, while most modern engines drop dead well before the 200,000-mile mark. These select power plants routinely roll past 300,000 miles. Their original blocks remain perfectly intact. Their original rotating assemblies keep turning. You do not need a miracle to get your truck to this milestone. You just need to stop listening to the absolute garbage advice inside your owner's manual. I have spent more than 15 years tearing down blown engines and diagnosing catastrophic failures. I know exactly why certain Fords survive while identical models end up in the scrap heap. The difference between a 150,000-mile paperweight and a 300,000-mile legend is not luck. It is your daily maintenance discipline. Today, we are exposing the hidden flaws of the 5 Ford engines capable of surviving the distance. We will look at exactly what kills them and how you can stop it before it costs you a fortune. Setting 5. The 3.5-liter EcoBoost V6. This engine has one of the most polarized reputations in automotive history. Half of the internet calls it a masterclass in performance, while the other half calls it junk. Both sides are completely right. You can easily push this twin-turbocharged V6 past 300,000 miles, but it demands more from you than any naturally aspirated engine on the road. The factory engineered this engine with direct injection to maximize fuel efficiency, but they hid a massive, costly flaw in the process. In a traditional port-injected engine, your fuel sprays directly onto the back of the intake valves. The gasoline acts as a constant solvent, washing away debris. Your EcoBoost bypasses the intake valves completely, spraying fuel directly into the combustion chamber. Because of this design, oil vapor from your PCV system continuously deposits onto the blistering hot backs of your intake valves. Without fuel to wash it away, this oil bakes into a rock-hard carbon crust. Over time, it restricts your airflow, chokes your engine, and causes severe rough idles. If you ignore this, the carbon eventually breaks off and scores your cylinder walls. You can fix this entire issue with a $150 professional walnut blasting induction service every 80,000 miles. If you neglect it, you are looking at a $9,000 complete engine replacement. Your turbochargers face a similar hidden danger. They are cooled and lubricated by your engine oil when you shut your truck off immediately after a hard drive. The temperature inside those turbo-bearing housings skyrockets, past 1,000 degrees Fahrenheit. This extreme heat bakes your oil into solid carbon deposits right inside the oil feed lines. If you use cheap conventional oil, or follow Ford's ridiculous 10,000-mile drain interval, you will starve and destroy your turbos before 130,000 miles. To hit 300,000 miles, you must run a premium full synthetic oil. Change it every 5,000 miles maximum. Never compromise on this interval. Setting 4. The 4.6-liter and 5.4-liter Triton V8, specifically the two-valve variants. This family of engines powered millions of F-150s, Expeditions, and police-spec Crown Victorias throughout the 1990s and 2000s. They are mechanically straightforward, utilizing a single overhead camshaft per cylinder bank, driven by a heavy-duty chain. The factory clearances are wide and highly forgiving. The lubrication system prioritizes absolute durability over peak horsepower numbers. However, the engineers made a devastating mistake in the cylinder head design. They gave the aluminum heads only 4 threads to hold the spark plugs in place, calmed, thin aluminum threads with thousands of thermal expansion cycles, and your spark plugs will literally eject themselves from the head while you are driving. When a spark plug blows out, it strips the threads instantly and destroys the ignition coil. Even worse, on the 5.4-liter models, the plugs can seize and snap completely in half during a routine removal. A standard $100 spark plug change quickly mutates into a $500 cylinder head extraction nightmare at a local shop. You can easily bypass this factory flaw. Replace your spark plugs every 60,000 miles before they have a chance to fuse to the aluminum. When you install the new plugs, Use a high-quality anti-seize compound and torque them precisely to 25 foot-pounds. Do not guess the torque. Additionally, your PCV system continuously dumps oil mist into the upper intake manifold. It creates a thick sludge that can eventually cause a lean misfire. Clean your upper intake manifold with a dedicated throttle body cleaner every 50,000 miles. Keep your cooling system fresh, or the intake gaskets will degrade and leak coolant into your cylinders. Setting 3. The 6.7-liter Power Stroke diesel. Introduced in 2011, this was the very first diesel engine that Ford designed completely in-house without any help from International. It is an absolute beast of an engine, built explicitly for brutal fleet work, heavy towing, and extreme hauling. The secret to its incredible lifespan is a block cast from compacted graphite iron, or CGI. CGI is twice as strong as conventional gray cast iron and significantly stiffer than aluminum. It resists warping and cracking under the immense cylinder pressures generated by modern turbo diesel combustion. The cooling system is equally impressive. The engineers used a reverse flow design that sends cold coolant to the cylinder heads first. This keeps your combustion chamber temperatures incredibly stable and stops head gaskets from blowing. But Ford paired this magnificent engineering with an incredibly fragile, complex emission system. The exhaust gas recirculation cooler is the silent killer of the 6.7-liter Power Stroke. Over time, thermal stress causes microcracks to form inside the EGR cooler core. This allows engine coolant to leak directly into your intake manifold. Because liquid does not compress, a major coolant leak will hydro-lock your engine. It will instantly bend your connecting rods and shatter your pistons. An $80 chemical coolant test kit will reveal early EGR failure before it manifests as white smoke at startup. Spend the money on early diagnostics, or prepare to write a $15,000 check for a brand new long block. Flush your coolant every 60,000 miles to keep the chemistry from turning acidic. Setting 2. The 5.0-liter Coyote V8. When Ford dropped this high-revving, aluminum block, dual overhead cam V8 into the F-150 back in 2011, truck purists lost their minds. They claimed an engine with variable valve timing belonged in a sports car, not a working truck. 14 years of hard data proved them completely wrong. The Coyote is a masterpiece of modern engineering. It features chain-driven cams, forged steel connecting rods from the factory, and a massive oil capacity designed to keep everything lubricated. But its greatest asset is also its single biggest vulnerability, the Twin Independent Variable Camshaft Timing System, or TIVCT. Uses hydraulic cam phasers to constantly adjust timing based on engine load. These phasers rely entirely on your oil pressure. Feed through incredibly tiny oil passages that measure only a fraction of a millimeter. If you use low-quality oil, or if you wait for the dashboard oil light to turn on before changing it, those tiny passages clog with varnish. Your oil pressure will drop below the required 15 psi at a hot idle. This causes the cam phasers to lose control, slackening the timing chains. Once that happens, your chains will start slapping against the plastic guides, chewing them to pieces. A complete cam phaser rebuild costs between $2,000 and $4,000 at a reputable shop. You can completely prevent this by avoiding cheap filters. Spend $40 on a premium synthetic oil filter and a high-grade 5W20 or 5W30 full synthetic oil. Change it every 5,000 miles without exception. Setting 1. The 7.3-liter Power Stroke diesel. This is the undisputed king of longevity. Built from 1994 to 2003, this massive V8 diesel regularly hits 400,000 and 500,000 miles without ever having its oil pan removed. The bottom end was built by International with massive mechanical margins because they designed it for commercial medium-duty trucks. The crankshaft, connecting rods, and pistons are twice as heavy as necessary for the horsepower it produces. It utilizes a hydraulically actuated, electronically controlled unit injector system, known as HATE-UE. This means your fuel injectors do not use a modern high-pressure common rail. Instead, they use your engine oil pressure to force fuel into the cylinders. A high-pressure oil pump fires your motor oil up to 3,000 psi to activate those injectors. This extreme pressure shears the oil molecules apart at a rapid rate. If you run conventional oil past 5,000 miles, the oil loses its viscosity completely. It shears down to the thickness of water. Then, sheared oil cannot protect the internal intensifier pistons inside your fuel injectors. It will wear them down, causing severe hard starting issues and eventual injector death. A fresh set of high-quality injectors will easily cost you $5,000. A premium oil change costs you just $120. Every single 7.3-liter Power Stroke that has ever crossed the 400,000-mile mark had an owner who changed the oil exactly on time. The mechanical components are completely bulletproof, but they are entirely dependent on the fluid you put inside them. There is a terrifying common thread that connects every single high-mileage engine on this list. It is something that most truck owners completely misunderstand until it is too late. The manufacturer guidelines in your glove box are not designed to make your vehicle last 300,000 miles. They are designed to lower the perceived cost of ownership during the first 3 years. If you follow their recommended 10,000-mile oil changes and 150,000-mile coolant flushes, you are walking into a carefully laid trap. But there is an even bigger, more destructive engineering flaw hidden inside Ford's modern drivetrain philosophy. It is a defect that can destroy your entire truck before your engine even gets it to shine. Setting 2. The 6R80 and 10R80 automatic transmissions. You cannot roll past 300,000 miles if your transmission explodes at 120,000 miles. Yet Ford's factory maintenance schedule is actively setting you up for exactly that failure. The manufacturer explicitly states in your owner's manual that the transmission fluid is filled for life, or only requires servicing every 150,000 miles. This is an absolute lie designed to keep corporate fleet costs looking low on paper. In the real world, it is a death sentence for your gears. Let's look at the engineering reality inside the 10R80 10-speed automatic transmission. This unit operates with incredibly tight clutch pack clearances and utilizes ultra-low viscosity Mercon UL fluid to reduce parasitic drag and hit fuel economy targets. Because the fluid is so thin, it degrades rapidly under the extreme thermal loads generated when you tow or drive in stop-and-go traffic. As the fluid breaks down, its friction modifiers deplete, and the operating temperature inside the valve body regularly spikes past 220 degrees Fahrenheit. At this temperature, the microscopic metal shavings naturally produced by clutch wear turn into an abrasive polishing paste. This debris clogs the highly sensitive solenoids and scores the aluminum bores inside the main valve body. Once those bores wear out by just a few thousandths of an inch, hydraulic pressure drops, causing delayed shifts, violent gear bangs, and eventual total clutch destruction. The economic stakes here are devastating. A routine transmission fluid exchange and filter replacement costs you about $250 at an independent shop. If you ignore it and follow the factory's 150,000-mile recommendation, you will experience catastrophic internal failure. A complete remanufactured 10R80 replacement will easily drain $7,500 to $9,000 from your bank account. Your actionable fix is non-negotiable. Throw the owner's manual in the trash. Flush your transmission fluid and drop the pan to replace the internal filter every 45,000 miles. If you regularly tow heavy loads, cut that interval down to 30,000 miles. Always insist on genuine motorcraft fluid, and never let a cheap lube shop use a generic multi-vehicle fluid that lacks the precise viscosity requirements of your specific transmission. Setting 1. The PTU power transfer unit in all-wheel drive EcoBoost vehicles. If you own an all-wheel drive Ford Explorer, Flex, or Taurus powered by the EcoBoost engine, you are driving around with a ticking time bomb bolted right next to your exhaust pipe. Ford designed these platforms with a transverse engine layout and an all-wheel drive power transfer unit to send torque to the rear wheels. The manufacturer claimed this unit was sealed for life, meaning it never required a fluid change. This single engineering oversight has sent thousands of perfectly good vehicles straight to the automotive graveyard. The engineering reason for this failure is pure thermal abuse, combined with an insanely inadequate fluid capacity. The PTU holds a pathetic 18 ounces of gear lube. To make matters worse, Ford bolted this tiny, uncooled aluminum box directly underneath the blistering hot turbocharger and exhaust downpipe. The radiant heat from the exhaust cooks the PTU constantly, pushing internal fluid temperatures well past 300 degrees Fahrenheit. Under this extreme heat, the factory-installed 75W140 gear oil undergoes severe thermal degradation. It literally turns into a solid black, tar-like sludge that completely loses its ability to lubricate the internal ring and pinion gears. Without lubrication, the gear teeth grind themselves to dust, the internal bearings seize, and the unit eventually cracks its own case, throwing metal fragments onto the highway. The cost comparison here exposes the absolute absurdity of factory neglect. A quart of high-quality synthetic gear oil costs less than $25, and a manual fluid extraction takes less than an hour of labor. If you leave it alone and let the factory sludge destroy the unit, the replacement PTU part alone costs $1,200. And the complex labor required to drop the subframe to install it pushes the total bill past $3,500. Your actionable fix requires immediate intervention. If your vehicle does not have a factory drain plug, you must use a vacuum extraction pump to suck out the old fluid through the fill-up plug. Do this every 30,000 miles without fail. Refill the unit with a premium, high-temperature, full synthetic 75W140 gear lube. If the extracted fluid smells like burnt sulfur and looks like tar, flush it twice to ensure all the baked contaminants are completely gone from the gear case. The hidden reality of reaching 300,000 miles has nothing to do with buying the newest truck or relying on advanced factory technology. In fact, the newer and more complex the vehicle, the harder the manufacturer tries to prevent you from servicing it yourself. They hide drain plugs, they eliminate dipsticks, and they write fantasy maintenance schedules that ensure your vehicle wears out right as the new models hit the showroom floor. But if you understand the mechanical weaknesses, ignore the corporate marketing, and treat your fluids as the lifeblood they are, you can outsmart the system. However, there is one final catastrophic system failure that most owners never see coming until their cabin fills with smoke and their dashboard goes completely dark. Setting 2. The electronic throttle body and plastic intake manifold. Before we hit the absolute worst component on modern Fords, you need to understand how a $150 plastic part can secretly strangle your engine and trick you into buying a brand new transmission on almost every modern Ford engine, from the naturally aspirated 3.5-liter V6 to the EcoBoost line. The factory uses an electronic throttle body with internal plastic GRS and an intake manifold made entirely of composite plastic. The engineers swapped out Durapal aluminum for plastic to shave off a few pounds for fuel economy and save pennies on production costs. The engineering issue is that these components are subjected to brutal, continuous thermal cycling right in the engine bay. The composite intake manifold is forced to handle up to 15 to 20 psi of boost pressure on EcoBoost models while absorbing radiant cylinder head heat that regularly tops 200 degrees Fahrenheit. Over 100,000 miles, this heat dries out the plastic, causing microscopic hairline cracks to develop along the mold seams and around the intake runner gaskets. This creates a massive, unmetered vacuum leak. Air slips into the engine, completely bypassing the mass airflow sensor, throwing off the air-fuel ratio. At the exact same time, the plastic gears inside your electronic throttle body wear thin. The teeth strip out, causing the throttle plate to flutter uncontrollably or stick completely. This drops your truck into a sudden limp mode, throwing a wrench light on the dash and causing severe gear hunting that mimics a failing transmission. Unscrupulous or uneducated mechanics will see these symptoms and instantly try to sell you a $4,500 transmission rebuild or a complete top-end engine teardown. In reality, the entire problem is a cracked $200 plastic manifold or a stripped throttle body gear. The cost comparison here is stark. Diagnosing this yourself with a $20 can of intake cleaner and replacing a failing throttle body costs about $150 and takes 30 minutes in your driveway. Letting a dealership misdiagnose the resulting drivability codes can easily lead to thousands of dollars in unneeded torque converters, sensors, or transmission components. Your actionable fix is straightforward. Every 60,000 miles, perform a smoke test or spray a light mist of intake cleaner around the intake manifold seams while the engine is idling. If the RPMs dip or spike, your plastic manifold is cracked or the gaskets have collapsed. Replace them immediately. If your truck exhibits a sudden, unexplained drop in power with a wrench icon, do not panic. Unbolt the electronic throttle body, inspect the internal plate for carbon binding, and replace the unit before letting anyone touch your transmission. Setting 1. The internal water pump on the 3.5-liter and 3.7-liter Cyclone V6 engines. We have arrived at the absolute pinnacle of engineering idiocy. This is the most deceptive, deeply hidden, and destructive factory flaw in Ford's modern history. If you drive a Ford Explorer, Edge, Flex, Taurus, or Lincoln MKX built between 2007 and 2020, with a transverse-mounted 3.5-liter or 3.7-liter Duratec V6, you are driving a vehicle that can completely destroy its own engine block overnight without a single drop of coolant ever hitting your driveway. The manufacturer hid this component deep inside the engine block structure. Completely shielded from view, the engineering reasoning behind this design defies all mechanical logic. Instead of mounting the water pump externally where it belongs, driven by a simple accessory belt, Ford engineers chose to mount the water pump inside the front timing cover. They ran the water pump directly off the internal engine oil lubricated timing chain to make this configuration work. The water pump shaft utilizes a dual-lip rubber seal to keep the pressurized engine coolant on one side and the engine oil on the other. The catastrophic flaw is that rubber degrades over time when exposed to the thousands of heat cycles inside an engine block, when that inner rubber seal inevitably hardens, cracks, and fails. The pressurized coolant bypasses the pump housing completely. Instead of leaking onto the ground to warn you of a problem, the coolant dumps directly into the engine oil pan. Coolant and motor oil mix instantly, turning your oil into a thick, milky, corrosive sludge because glycol completely destroys the oil's film strength. Your crankshaft bearings, cam journals, and piston recips lose all lubrication within miles. The engine will spin a main bearing and lock up completely while you are driving down the highway, often without a single warning light appearing until the engine is already dead. The economic reality of this single part is absolutely mind-boggling. A replacement water pump part costs a measly $80, but because it is buried inside the front timing assembly, changing it requires a massive 12 to 14-hour labor job that costs upwards of $2,000 at a shop if you ignore it and let that $80 pump fail internally. The resulting bearing wash destroys the entire engine block. A complete engine replacement on an Explorer or Edge runs between $7,000 and $9,500. Your actionable fix requires extreme vigilance. You cannot afford to wait for symptoms. Check your oil dipstick every single week. If the oil looks like chocolate milk or has a creamy residue under the oil fill cap, do not start the vehicle. Furthermore, look through the passenger side wheel well at the front of the engine block. Ford built a tiny weep hole into the block casting behind the alternator. If that internal pump seal starts to fail, a small amount of coolant will seep out of this specific hole before the main seal completely lets go. If you see crusty orange or green stains dripping down the back of your alternator, your water pump is dying. Park the vehicle immediately and get that pump replaced before it dumps gallons of water into your oil pan. Every high-mileage legend rolling down the road right now has one thing in common: an owner who actively fought back against manufacturer defaults. If you want your vehicle to survive to 300,000 miles and beyond, you must implement these strict discipline-based fixes starting today. EcoBoost engines. Throw away the 10,000-mile recommendation. Run full synthetic oil, change it every 5,000 miles. And perform a walnut blasting valve service every 80,000 miles to keep the intake tract clean. Triton V8 engines. Replace your spark plugs every 60,000 miles using precise torque specs and anti-seize to prevent catastrophic plug ejection or breakage. 6.7-liter power stroke. Chemically test your coolant every 30,000 miles to catch a failing EGR cooler before it hydrolocks your engine blocks. Transmissions. 6R80, 10R80. Disregard the filled for life marketing trap. Flush the fluid and swap the internal filter every 45,000 miles to protect the valve body solenoids. Power transfer units, PTU. Vacuum extract and replace the tiny 18-ounce fluid capacity every 30,000 miles to stop the gear oil from cooking into solid tar. Cyclone V6 engines. Inspect the engine weep hole behind the alternator weekly and watch your dipstick for milky coolant contamination.